y is equal to x sine y. Okay, it is given that y is equal to x sine y, and you need to prove that x dy dx is equal to y by 1 minus x cos y. Okay, x dy dx is equal to y by 1 minus x cos y. So we start with this, y is equal to, given y is equal to x sine y. Okay, differentiating both sides. With respect to x, we get ddx of y is equal to ddx of x sine y. That means dy dx is equal to x ddx sine y plus sine y ddx of x, which is equal to, now see, ddx of sine y. How do will I differentiate this? I will first differentiate this with respect to y. So x I will write as
Yes,
it
sir.
is. ddx of sine y with respect to y is cos y, and I will multiply this with dy dx plus ddx of x is 1, so this remains simply sine y. Okay. Um, this. So what are you getting? You are getting dy dx is equal to x cos y dy dx minus sine y. So I take all the dy dx together on one side. So I get dy dx. I get dy dx minus x cos y dy dx is equal to sine y. Okay. Now I take dy dx common.
Yes, sir.
1 minus x cos y into dy dx is equal to sine y. And therefore dy dx is sine y by 1 minus x cos y. Yes, that is what we needed to prove.
Yes, sir.
So that is done. Okay. Next one. Next one is uh, if ax square plus 2hxy plus dy square is equal to c square, verify that dy dx into dx dy is equal to 1. Okay. So there are two ways. First you have to find dy dx and the other you have to find dx dy. Now you might ask, what is dx dy? Okay. Differentiation of y with respect to x is dy dx. Differentiation of x with respect to y is dx dy. Okay, so
Yes, sir. Yes, sir.
first we find dy dx. Differentiating both sides. With respect to, first we differentiate with respect to y. Okay, then we'll differentiate with respect to x. So you get ddx of ax square plus 2hxy plus dy square is equal to ddx of c square. Next, ddx of ax square plus ddx of 2hxy plus ddx of by square is equal to 0. Now a is a constant, I can take it out of the differentiation. A ddx of x square. 2h is a constant, so I can take it out. 2h ddx xy. B is a constant, I can take it out. Okay, now ddx of x square is 2x, so this becomes 2x plus 2h, and this you differentiate by u into v. X ddx of y plus y ddx of x plus ddx of y square is, first we differentiate with respect to y to get 2y, so you get 2by into dy dx. This step is okay.
Yes, sir.
So proceeding further, you have 2ax, you open the brackets, 2hx, this is dy dx, so 2hx dy dx plus ddx of x is 1, so y 2hy, so 2hy, okay, plus 2by dy dx is equal to 0. That means now you take these two dy dx together and the others together, 2ax plus 2hy plus 2hx plus 2by dy dx equal to 0. That means 2hx plus 2by dy dx is equal to minus 2ax plus 2hy. That means dy dx is minus hy divided by 2hx plus 2by. So now I can cancel 2 from both sides, from numerator and denominator. Therefore dy dx becomes minus ax plus hy divided by, agreed or not? Cancel 2. Agreed?
Yes, sir.
Now what I proceed to find dx dy. Okay, now how to find out dx dy? Let's see. Again you have ax square plus 2hxy plus by square equal to c square. This time I write differentiating both sides with respect to x, not with respect to y. Sorry, differentiating both sides, this should be with respect to x. Okay, because I have a x here. So this time I'll write differentiating both sides with respect to y. Okay, we get what? ddy of ax square plus by square is equal to ddy of c square. Can I write or not?
Yes, sir.
Now see, the y is the variable here. Okay, we proceed exactly in the similar manner as we do with x, except that we must realize that y is the variable. So ddy of ax square plus ddy of 2hx hxy plus ddy of by square. This is y square is equal to 0. Now see, I am differentiating x with respect to y. First, let me take out the constant, then I will see. 2h d dy of xy plus b d dy equal to 0. Okay, next is ddx of see, I'm differentiating x with respect to y. So first I'll differentiate x square with respect to x to get 2x, and then I'll differentiate x with respect to y. Do you agree with this?
Yes, sir. Yes, sir.
Amir is not there.
Yes, sir. Ami is there.
No, he's not there.
Again he left. Again he
Uh,
left
Maybe
because of
connection problem.
network problem. That's
Mm.
yes, sir.
Plus 2h, and then you differentiate this by UV rule. First is x d dy of y plus y d dy of x
Hello. Yes,
yes
sir. No, nothing, sir.
plus
Before the screen was not appearing. That's why
okay.
I'm saying.
Now d dy of y square is what? D dy of y square is 2y, right? Simply 2y,
Yes,
because this variable and this variable is the same. So I get
yes,
2ax dx dy plus 2hx dy of y is 1, so simply 2hx plus, and you have 2hy dx dy plus 2by equal to 0. That means you have um, 2ax plus 2hy dx dy plus 2hx plus 2by equal to 0. So that means 2ax plus 2hy dx dy is equal to minus of all this. 2hx plus 2by. That means dx dy is minus 2hx plus 2by divided by 2ax plus 2hy. Now you can cancel out the 2 to get minus hx plus by divided by ax plus hy. Now the question here was, if you see, the question here was verify that dy dx into dx dy is equal to 1. So let's verify. What have we got? Left hand side, LHS is equal to what? Dy dx into dx dy. And what have we found? Dy dx, we have found this. So substitute the value, minus ax plus hy divided by hx plus by. Okay. Into what is dx dy? This. So this is minus hx plus by divided by ax plus by. See, this and this will cancel. This and this will cancel. You're simply left with minus 1 into minus 1, which is plus 1, which is equal to your RHS. Proved. Clear?
yes, sir.
So let's move to the next one. Now remember, there's one result which I have not told you. That see, in fact, what you can do is, you can, if you want to calculate, just remember this, okay? If you want to calculate dx dy from dy dx, remember that if you dy dx is equal to, they are reciprocal of each other, is equal to 1 by dx dy. Understood?
Yes, sir. Yes, sir.
Or you can also write dx dy is equal to 1 by dy dx. Okay, this is not your normal fractions, okay? Although it looks like, but this is not your normal fraction, remember. Okay,
Yes, sir.
dy dx is not a normal fraction. Let us, I think you can do number 15 on your own. Let us look at number 16, this one. Y log x, given y log x is equal to x minus y. Okay, you need to prove that dy dx is equal to log x by 1 plus log x whole square. Now there are two ways of doing. Okay, one is by implicit function and one is by normal way. Let us see how to do by normal way first. What you do is you take the y's together. In fact, this implicit function can be expressed as an explicit function. Y log x is equal to x minus y. You take the y's together. Y log x plus y is equal to x. That means y you can take common. You get 1 plus log x is equal to x. That means what is y? X by 1 plus log x. So if you see, this y has been expressed as an explicit function of x. Correct or not?
Yes, sir.
And then you can differentiate by u by v rule. This is your u, this is your v. Okay,
Yes, sir.
you can do this method. But since we are discussing implicit functions, I'll do by implicit functions here. So given y log x, differentiation of implicit functions, I'll do by differentiation of implicit function, differentiating both sides. With respect to x. D dx y log x is equal to d dx x minus y. That means d dx, so let me first write y d dx of log x, u into v rule, plus log x d dx of y is equal to d dx of x minus d dx of y, which is dy dx obviously, and y d dx of log x is 1 by x, right? So y into 1 by x plus log x d dx of y is dy dx. d dx of x is 1 minus dy dx. Now you collect the dy dx terms together. Okay, so this is y by x, this one. So therefore, if I collect, I will get log x dy dx plus dy dx is equal to 1 minus y by x. One plus log x dy dx is equal to, let us take the LCM here, x minus y. That means dy dx. Oh, why have I kept y there? Oh, no problem. dy dx is equal to x minus y by x into 1 plus log x. Okay, but what we had to prove? We had to prove that log x by 1 plus log x, isn't it? Right? We had to prove this, right? Can you hear me?
Hello. Yes, sir. Now I can hear.
We had to prove
Yes,
this,
sir.
right?
Now I can hear.
We had to prove this, right? But what are we
Yes, sir.
getting? What are we getting? We are getting this, right?
Yes,
So
sir.
this actually can be expressed as this. Now see x minus y. What is x minus y? What is x minus y? Tell me what is x minus y?
Sir, x minus y.
Yes.
Sir, x minus y is 1.
Y log x.
Uh,
See, x minus y is equal to y log x. So I put back the value of
yes, sir.
x minus y here. Divided by
Okay.
x.
X
And I have in the denominator, what do I have? 1 plus log x whole square.
1 plus log. Yes, sir.
Okay, so what I do is, what is 1 plus log x from here? My function was this, right? That means
Yes, sir.
here I can write y log x. In fact, you can put back the value of y simply. See,
Yes, sir.
what you can do is, you can calculate y from here. So let me do it here. This I've already done here. Okay, but still I'll do again. See, I've done here. I've calculated the value of y. Okay, so let me do once again. Y log x is equal to x minus y.
Yes, sir.
Now, y log x is equal to x minus y. So I'll calculate the value of y. Y log x plus y is equal to x. That means y is equal to y into 1 plus log x. One plus log x is equal to x. That means y is equal to x by 1 plus log x. Okay. Now what I'll do is, I've got dy dx here. I'll simply substitute the value of y. Yes, so what I'll do is x minus x by 1 plus log x. And you already have x into 1 plus log x. There is no y in the denominator. Okay. So now if you simplify, take the LCM, x plus x log x minus x divided by 1 plus log x divided by 1 plus log x, right? So therefore, what do you get from here? This x and this x cancels. You get x log x by 1 plus log x whole square. So am I getting the required expression or not?
Yes.
Getting this. Okay, so what we have done here is that we have differentiated the implicit function. Okay, and we found out an expression for dy dx, and we are putting back the value of y after finding out the value of y from the function. From the function, I've found out the value of y, and I'm putting the value of y
Yes, sir.
here to get my required expression. Okay, because what I see here is that,
Okay,
see,
sir.
what we have to prove here is that everything is in terms of x on the right hand side. Okay, isn't it? Is there any y in the right
Yes.
hand side? There is no y. That means, but in dy dx here, I
No.
was getting a y, and I had to remove this y. So that is why I substituted the value of y in terms
Yes.
of x. Okay, so moving
Okay, sir.
forward with this is a it's very important
Yes, sir.
problem. This one, yeah, this is a very important problem. Um, Next one is let me do this. This looks tough, but actually it is not tough. Given root y by x
Yes.
plus root x by y is equal to 6. You need to show that dy dx is equal to x minus 17y divided by 17x minus y. Okay, so what I do here is that I write this as root y by root x plus root x by root y is equal to 6. Now I take the LCM, root x into root y. Okay, so what should be root x into root y divided by root x is root y. So I'll get root y into root y plus, similarly here I'll get root x into root x is equal to 6. So what I get is y plus x by root xy is equal to 6. That means y plus x is equal to 6 root xy, right? Now I'll differentiate both sides with respect to x.
Okay, sir.
Differentiating both sides respect to x, we get d dx okay, d dx of y plus d dx of x is equal to 6 d dx. And I separate here also root x into root y because I'm going to use u into v rule. So next I will have dy dx plus 1 is equal to 6 root x d dx of root y plus root y d dx of root x. Okay, dy dx
Yes.
plus 1 is equal to 6. Root x remains as it is. How do you differentiate root y with respect to x? First you differentiate root y with respect to y. You get 1 by 2 root y. And then you multiply by dy dx plus root y, and 1 dx of root x is 1 by 2 root x. Okay, so I get dy dx
Okay, sir.
plus 1 is equal to 6 times um, root x by root y dy dx. Oh, this cancels also. So let me write it 2 here by dy dx. Okay, and here you get root y by 2 root x only. Okay, now you multiply, take the dy dx together. Dy dx plus 1 is equal to, if you multiply this, what you get? Root x by 3 root x by root y dy dx plus root y by root x, let's say 2 root x. Oh, this cancels with 3. See, this 6 will cancel with this 2, right? To give you 3 root y.
Yes, sir.
Now I take the dy dx together. Dy dx minus 3 root x by root y dy dx is equal to 3 root y by root x minus 1. Okay, that means dy dx is 1 minus 3 root x by root y is equal to 3 root y. Take the LCM, you get this. Okay, so That means take the LCM here also. Root y minus 3 root x. 3 root y minus root x. Root x. Okay. So that means now what do I get? Dy dx is equal to root y into 3 root y minus root x divided by root x into root y minus 3 root x. Now if you multiply everything, you get 3y minus root x into root y divided by root x into root y minus 3 root 3x. What you had to prove? You had to prove that dy dx is x minus 17y.
X minus 17y upon
Right?
17x minus y.
X minus 17y. Mhm. 17y. Have I copied the question correctly? Yes, the question is okay. 17y. Why 17y? 3y minus root xy. What is root xy? This. Hmm. Root y by x plus root x by y. Should work in this way also. Root x root y plus root x by x. Yes, yes, this will work. So this is, now see from here, uh, from this step. Yes, from this step. What is the value of root xy? 5 plus x by 6, isn't it? Yes? Did you understand? From this step, I take out the value of root xy is equal to y plus x by 6 and put it here.
Sir, not understand. No,
Could not understand.
no.
See, here what I have done, till here what I have done, I have only simplified, right? And then I have differentiated from
Yeah.
here. Now see what I am getting. I am getting here root xy, isn't it? Dy dx is equal to something in root xy. Okay, but what the way I have to prove, is there any root here? Is there any root here? There is no root here. That means we will have to remove this radical from here. That means we will have to remove this root xy from here. Okay, and how do we remove this root xy? By finding out the value of root xy from the given function. What is root xy? It is y plus x by 6. Okay, so I have put it. Now you understood. Now take the LCM. (18y minus y minus x). Y plus x minus 18y. 18x. So ultimately this 6 and this 6 will cancel. We'll get 17y minus x divided by x minus Oh, sorry. This is x minus 18x is minus 17x. So y minus 17x. Have we got this? Yes, x minus 17y. You can write it, you can take minus common. Minus x minus 17y divided by minus 17x minus y. So this one is cancelled. So you get x minus 17y divided by 17x minus y. See, check now whether I have got this. This is what I have got is x minus 17y by 17x minus y. And I had to prove dy dx is equal to x minus 17y by 17x minus y. Clear? Okay. Move on to the next one.